In this section, we will learn about Pack Geometry Manager. We will start with the overview of Pack Geometry Manager, and then we will talk about the options available in Pack Geometry Manager. After that, I will show you how to add widgets using Pack Geometry Manager, and then we will discuss some useful methods associated with Pack Geometry Manager. These are forget, configure, slaves, info, etc. Pack is a beginner-friendly geometry manager that is used to pack the widgets on the screen in the vertical blocks. Each widget is placed in the series of their creation. By default, the widgets are placed at the center top of the application window, but this can be adjusted with the available options in the Pack Geometry Manager. So this is the syntax of Pack Geometry Manager, where you have to provide the name of the widget dot pack as a keyword, bracket open close, and these all are the options that you can provide. So we have mentioned these options in detail over here. Now let's go ahead and create the widget and pack it using the Pack Geometry Manager on Tkinter window. So I have a basic template ready with me, and I will go ahead and create one widget. So the name of the widget is label. We will talk more about these widgets in future sections. So let me provide a text as a primary text, and let me give a border to it so that we can see its size. Now, once you have created the widget, you have to provide the name of the geometry manager. So in our case, it is pack. So let's go ahead and run the program. Python main.py, sorry. So here you can see that our widget is appearing on the Tkinter window. By default, the side of the application is on the top of the window, but you can change it in case if you want to display it over here or here or here. You can just change it using the side. So if I will type side is equal to left, save the program, run it once again, you can see that it is appearing on the left side, and so on. Next option is expand. Expand accepts boolean values. Either you can provide true, false, yes, no, or 1 or 0. So let's type true over here. So what it does, it will allow the application to expand in the available space. So if there is any space available, the application will be expanded. It do not work all alone. It requires one more option with it. It's called fill. So fill decides in which direction you want to fill it. So it accepts three parameters. First is none. By default it is none. And second is XY. If you want to stretch the application, if you want to stretch the widget in the X axis, then you can provide capital X over here. To stretch it in the y axis, you can provide capital Y over here. In case if you want to stretch in both the directions, then you can provide both over here. So if I will write both here, save the program and run it, you can see that the application has been stretched since the space was available. So the application has been stretched to the entire window, and if I will increase the size of the window, it will adjust itself accordingly. Now if I will just provide capital X over here, then it will be expanded only in the X axis. Similar thing will happen with the Y. Fourth option in Pack Manager is Pad X. So Pad X adds horizontal space outside the widget on X axis. So this is how the application looks like right now, and in order to demonstrate the Pad X, I have to create a couple of more widgets. So I will copy and paste it 2 times. Now let's see once again how it looks like. Now you can see that all the widgets are occupying all the space and they are connected to each other directly. There is no space between them. Now if I will add Pad X over here, let me go ahead and add it in the middle one. So pad X is equal to 20. Now you can see that the space has been added, that is 10 pixels over here and 10 pixels over here has been added, and due to which all the widgets are not connected directly to each other. If I will add the Pad X in this one as well, then there will be a space of 20 pixels here and 10 pixels over here. Similar thing will happen with the pad Y. It will add space in the Y axis. So let me go ahead and add pad Y equals to 10. Now you can see that 5 pixels has been added at the bottom and 5 pixels has been added on the top. That's how you can use pad X and pad Y. Our last pair of options are iPad X and iPad Y. iPad X adds horizontal space within the widget on X-axis, whereas iPad adds vertical space within the widget on Y-axis. So in order to demonstrate that, I have to remove expand equals to true and fill equals to both options from the pack, so that I can show you, because it adds space over here and over here. Now in order to add iPad X, I will just use the keyword that is iPad X equals to, and the value that I will provide is 10. Save the program and run it. You can see that there is some space added over here. So let me add more so that you can see it properly. So let me add 50 here. So now you can see that the widget has been extended by 25 pixels, 25 pixels on the right and 25 pixels on the left. And similar thing you can do with the iPad Y as well. iPad Y equals to 50. So here you can see that 25 is added over here and 25 is added over here, and this position is fixed now. Like if I will change the size of the application, it won't change. So before moving forward, I want to discuss one more feature of pad X and pad Y. Before I explain that, let me make some changes in the program. So right now you are seeing the space over here, here and here. So in case if you want to provide space in one direction only, so that thing also can be done using pad X and pad Y. So what I am going to do, I will keep this space on the Y axis, and I will remove this space. If you will put it inside of brackets, and now you can provide the input for the top and bottom. So first is top and another one is bottom. Since I need space on the top, so I will keep it 10 and I will add 0 over here. So this is how you can see that there is a space here but no space at the bottom. So this thing can be controlled. Similar thing can be done with the x-axis as well. I will be adding space over here, but I will remove space for this one. So I will just keep it 20 and I will remove, oh sorry, I will add 0 here. Now you can see that the application is attached to the left, to the right side one, but there is a space for the left one. With this we have covered the pack options. Now I will show you how to create this project in Python Tkinter using Pack Geometry Manager. So this is a simple application based upon whatever we have learned so far. So in this application, these are the labels 1, 2, 3, 4, 5, and each label has a background color. So let's go ahead and create this application. So I have a basic template ready. Now I have to create a label. I want to place it on the WS, and then the background color that I want to provide. So in my case, it will be 5, 9. You can provide the color name or you can provide the hex code. Then height of the widget will be 2 and width will be 10. Now I have to pack it. Inside the pack, I will give it, I will assign it on the top, and I will allow it to expand to available space. And I want it to expand only in the Y direction. So let's go ahead and run first program. You can see that it is appearing like this. Now I have to create 5 more. So I will just copy and paste it 4 more times. Now I have to change the background color for each. Now let's go ahead and run it. You can see that our application has been created. Now if I want to provide a background color to the entire window, I can just go ahead and type ws.config and bg equals to 89864b. So this is how the application will look like now. So you can change the application, like right now it is in the horizontal position. You can change it to the vertical position by just simply changing the fill value in each of them, and also you have to change it to the left. So if I will set it to left and fill equals to X, let me go ahead and do for all of them. So now if I will run it, you can see that the program is appearing in the horizontal position. Also, if I will set it to the right, then white color will come this side. So this way you can create this application. Now we are going to start discussing some useful methods associated with pack. First method is pack-forget, which is used to destroy or delete the geometry manager. In order to demonstrate that, I will create a button, and whenever the user will click on the button will be deleted or destroyed. So this is the variable to store button widget. So this is the name of the function that will be triggered when the button will be clicked. Now I am going to create a function def. Now the name of the widget on which I want to apply the function. So btn dot pack forget bracket open close. Now let's run the program. You can see that there is a button on the application, and as soon as I have clicked the button, it has disappeared or it has been removed from the window. So this is how you can use the pack forget function. Our next method is pack configure. Pack configure allows to adjust the setting of existing pack manager. You can configure the following settings in pack configure, like you can change the after, anchor, before, expand, fill, etc. So let's go ahead and implement this. Like we have created for the pack forget, we will do the same thing over here. I will just change the names over here. And in this case, right now the size of the button is default. Now I will change the size of the button. So I will add some extra padding. Pad x is equal to 10 and pad y equals to 10. Let's run the program. Now as soon as I will click on this button, the padding will be applied on this button. So you can see that the button has moved to slightly below. You can add more paddings to it, like let me go ahead and add some internal padding. So ipad x is equal to 10 and ipad y equals to 10. Now if I will run the program, and when I will click on this button, you can see that the size of the button has also been increases and the position has also changed. So this way we can use the configure to change the settings in the real time. Our next method is pack slave. Pack slave returns a list of slaves of the widget in its packing order. So this is the syntax. So what it does, let's suppose you are using any parent widget such as frame, and you want to know all the child widgets of it. So you can use the pack slave method to know all the child widgets. So let's go ahead and implement this thing. So I am going to create a frame over here. Now inside this frame, I am going to create a couple of widgets. For example, let's add some label. And let me add one button. So now if I will run the program, you can see that there are primary text and primary buttons on the screen. Now print the slaves, or now I am going to print the slave for the label, for the frame, sorry. So print pack slaves, and I have to provide the name, which is frame over here, frame dot pack slaves, bracket open close. Now as soon as I have run the program, you can see that I'm getting the list of all the child widgets for parent frame. So you can see that we have label over here, we have button over here. So this is what you can do using the pack slave. Our next method is pack info widget return the information about the packing options for the widget. So it will return all the options that we are going to use. So for example, here we have not used any option for this, but still it will return the default settings. So I just need to change it from slaves to info. Now you can see that we have all these options. So anchor is set to center, expand is equal to 0, fill is none, iPad X is equal to 0, iPad Y equals to 0. So all these settings, I am going to change the settings. If I will change the settings, I will get the changed value over here. So let's go ahead and set expand equals to true, iPad X is equal to 10, iPad Y equals to 15. These are the random values. iPad Y equals to 10. Now let's run the program. Now you can see that expand equals to 1. So 1 is treated as a true. You can provide 1, 0, yes, no, anything. Fill is none, and iPad value has changed from 0 to earlier it was 0. Now it is 10. iPad Y is 15. Earlier it was 0. So this way. Our last method is pack propagate. Pack propagate method determines whether the child widget can increase the size of the parent widget or not, and it accepts the boolean values. So let me show you what I mean. So right now let me remove these options. Right now frame, we have not assigned any value to the frame, but still we are able to see the child widgets on it on the screen. So if I will run it, you can see that we can see the child widgets, and if I will increase the size of the child widget, you will be able to see it as that as well. So if I will increase the height and I will increase the width, you can observe the change. Actually parent widget is allowing it to expand to the size, whatever size it want. But if we want to restrict this thing, we have to use frame dot pack propagate. So if I will pass, so 1 is for yes and 0 is for no. So if I will pass 0 now, you will see that the button and label won't appear now. They are not appearing because the size of the frame is very small, because the size of the frame is very small. But if I will go ahead and increase the size of the frame, let's say I will provide some height to it. Height is equals to 50, width is equal to 30. Then you can see that now it is appearing. So the size of the parent window will decide whether the child widget will be able to show or not. So the size of the parent window will determine whether the child window will be able to appear or not, and child window has to adjust themselves accordingly. So right now you can see that the button is not coming completely and the label is also not coming completely because they have a bigger size, but the size of the frame is very less. That's why they are not appearing. So with this we have covered the pack geometry manager, and in the next section we will talk about the grid geometry manager.